Hey guys, what's up? Mr. Hart's back to you. Hopefully you guys had a good spring break. We are now going to be working on some reviews um, of the AP Calc course, getting ready for our modified AP exam that you guys are going to take from your own house. Just a couple reminders about that exam. The modified exam will be on May 12th at 1 p.m. Our time, Central Time. And you're going to be able to take that from home. There'll be 2 free response questions. It'll be a lot shorter than what the full exam that you would have taken under normal circumstances. But because of this stupid virus, I guess one nice thing is it's a little bit shorter. But we want to be as ready as we possibly can be. What I'd like you guys to do is from now until the test day, I want you to flip through your notebooks. You guys have really good notes. Start flipping through and just kind of reviewing each day and try and get through all of your notes in a week, right? And then go back and look at them again, okay? Let's say you're looking at your notes from day 7 and it doesn't really make sense. Well, just go back and rewatch the day 7 video. Okay, it's all out there for you, but it's going to be important from now until this test day. We got about a month to review everything as much as possible. I'll have you guys review in class and do some work. I also want you guys getting connected. We've done some AP classroom stuff, but I've mostly printed that stuff off for you in class. I'm going to be assigning some stuff on there as well. So take a look at that, and if you're having questions getting connected, let me know. But everybody had signed up for that, and look on there and I'll be able to assign you some work through there as well. Okay, so let's talk about derivatives today and just kind of do a reminder video on how derivatives work. Let's start with derivative rules. First rule we have is called the power rule. If we do the derivative of a function that's in the form ax to the n power, we take that exponent and we multiply it out front. So we'll get an out front, and then we reduce the power by 1. Okay, so that's our simple basic power rule of derivatives that we need to know. A couple of examples here. Okay, again, very simple here. I'm going to take my exponent, and multiply it out front. 3 times 8 is 24. And I have to reduce my power by 1, 2. Okay. So again, derivatives are very simple when they're in that ax to the n form. It's really easy to use the power rule. However, sometimes we're not in ax to the n form. We need to get to ax to the n form, do the derivative, and then convert back. So let me show you what I mean by that. This is still a power rule, even though it looks much more difficult. Okay, so now we're not in ax to the n form. So some things that we have to know. Square root means half power. So we want to think of this as f of x equals 8x to the half. So then to find f prime of x, right now this is an ax to the n form. I can do 8 times a half and I'll get 4x to the negative half. Okay? And that's a perfectly acceptable form to write your answer in. However, if you need to evaluate, right, if I need to plug in a number, like if I wanted to find f prime of 9, I would want it to be in positive exponent form, and I'd want it to be in root form if possible. So I like to take this and say, okay, I know a negative exponent, right? Since x has a negative exponent, I can drop that down to the denominator and call it a positive exponent. And I know a positive half exponent means square root. And I know that that's also, right, all 3 of these forms, if you follow my cursor, 1, 2, 3, all 3 of them are correct. They are f prime of x. Okay, this is the form that's really nice to be in order to plug in, right? If I wanted to f prime of 9, I could see, oh, that's 4 over root 9, that's 4/3, very simple. But 4 times 9 to the negative half is not as nice of a thing to work with there. Okay. Also, if you have something like this, right, find g prime. And this is not in ax to the n form. So I want to rewrite g of x to be in the form 10x to the negative 2. Now I can perform my derivative. Negative 2 times 10 is negative 20. And I have to reduce the power by 1. Negative 2 minus 1 is negative 3, not negative 1. And again, this could also be written in the form negative 20 over x to the positive 3. Again, both of these answers are right for g prime. This one is just much easier to plug into. Okay. Let's talk about some derivatives to memorize. First is the derivative of sine x. The derivative of sine x is cosine x. Again, we're talking about derivatives here, not integrals. You might say, hold on, the integral of sine is negative cosine. Correct. The integral of sine is negative cosine. But the derivative of sine is positive cosine. Okay, important to keep that straight. Derivative of cosine is negative sine. Derivative of tangent is secant squared x. What are some other ones that show up all the time? Well, we've got derivative of e to the x. It's e to the x, that's an easy one. Derivative of ln x is 1 over x. We've got well, there's some other ones. If we have the derivative of like a number like 2 to the x, the answer is 2 to the x times ln 2. I mean, it's always times the natural log of the base. Doesn't come up a ton, but it does come up. Another one that we see that sometimes shows up is derivative of secant x. Is secant x tangent of x. Okay. And there were a couple we didn't talk about, but I want you to get them in your notes. Derivative of arcsine. That's 1 over square root of 1 minus x squared. Again, you can just write these in your notes to have them with you in case they come up on this thing. Okay, just as a note, arcsine of x could also be written as arc of x. Those are both notations that can be used for inverse sines. And the last one is the derivative of arctangent. Note the difference here. There's no square root in the denominator. Instead of a minus, 1 minus x squared, it's 1 plus. This looks like a t, so that's how I remember that's the one for tangent. Okay, let's talk about our 3 other big rules that we have. Product rule. That states that the derivative of f of x times g of x is the derivative of the first times the second plus the first times the derivative of the second. Okay, one example here. Okay, so I notice here that I have a product of 2 functions. F of x can be thought of as 4x squared times sine of x. So f prime of x, then, I have to do the derivative of the first, which is 8x times the second, sine x, plus the first, 4x squared, times the derivative of the second, cosine x. Okay. The product rule is pretty easy, but we have to remember it and use it anytime we are doing the derivative of a product of 2 functions. Okay? Next one is quotient rule. That says the derivative of a function divided by a function gives you the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom function squared. Okay. So let's look at an example on that one. Okay, if f of x is 8x over tan x, f prime of x would be the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom function squared. Okay. Now, if this is a free response test, you probably don't need to simplify. This thing doesn't simplify anyway. Okay, please don't cancel out these 2 tangents, right? One of these tangents here, because there's no tangent, excuse me, there's no tangent in this term here. Okay. And then let's look at the chain rule. So when we have a composition of functions, we use the chain rule. We're doing the derivative of f of g of x. We do the derivative of our outer function with respect to our inner function, f prime of g of x times g prime of x. Okay? I'll do a few examples here. Example 1. So when I look at this, I see e is my outer function, 6x squared is my inner function. So my derivative would be the derivative of the outside, e is its own derivative, with respect to the inside, 6x squared, and then I'd multiply by the derivative of the inside, which would be 12x. Okay, which I'd probably write as 12x e to the 6x squared. Okay. Example 2. I'm going to do the derivative of cosine of 4x cubed. This is my inner function. This is my outer function. So f prime would be the derivative of the outside, negative sign, with respect to the inside, 4x cubed. It's not negative sign x, it's negative sign of 4x cubed. And then I would have to multiply by the derivative of the inside, which would be 12x squared. Okay? So cleaning this up, I'd call it negative 12x squared sine of 4x cubed. Okay? Example 3. So I have tangent to the 5th power of x. As a reminder, when I'm trying to find g prime here, that this means literally tangent of x to the 5th power. When we write it in that form, we can see tangent is actually our inner function, x to the 5th is our outer function. So when we go to do g prime, we do the derivative of the outside with respect to the inside times the derivative of the inside. Make sure you forget the chain part of the chain rule. We're always chaining on that times derivative of the inner function. It's multiplication, right, is the operation there. So writing this thing out, cleaning it up, I'd call this 5 tan to the 4th x. So I'm going to give you practice over the next few days that's going to be derivative heavy. I want to make sure that we are 100% rock solid on accurately performing derivatives over and over again. So you'll see practice for the next couple of days here that has to do with derivatives. Some of the practices I'll send you. Some of the practices I'm going to try on AP Classroom. So let me know if you're having trouble getting into that. And let's get ready to study as hard as we can for this. Again, just as a reminder, make sure you are going through all of your notes. Oh, one more thing I wanted to add to this video. Hopefully you didn't turn it off already. How do we know how to do a derivative? Okay. Here here are some things that tell us to do derivative. d dx, dy dx, f prime of x. Those are all meaning derivatives. Okay. Instantaneous rate of change. Is a keyword to do a derivative. Slope of the tangent line or equation of a tangent line. Those are all things that tell us to do a derivative. Okay. Also, think about your position, velocity, acceleration. If they give you a position function and they ask you about velocity, that means we need to do a derivative to go from position function to velocity function. Derivative of velocity gives us acceleration. Okay. So just be prepared. I might think of some more here. But that's it for today. This video should be good. I probably won't have one on Friday. So we'll just do more derivative practice for a little bit here. All right, that's it for today. I'll talk to you guys later. Hang in there. I know this is crazy, but let's do the best we can on this AP exam and get that college credit. Talk to you guys later. 2 chains. Bye.